Let's look at question number 1 on the study guide. Factor or expand each expression. You can use a rectangle diagram to organize and support your work, however, this is not required. Let's see an example of this. Right here, I see a length times a width. That makes me think rectangle. So let me draw a rectangle to represent the situation. My length is 3. My width is 2x minus 5. 3 times 2x is 6x. 3 times negative 5 is negative 15. So I can expand this expression by writing it as 6x minus 15. I'm done. You are not required to use a rectangle diagram, though you should show your work. Here is another way to show your work. You can draw an arrow showing the multiplication of each piece. Negative 4 times 0.5y is the same as half of negative 4. So that's negative 2y. Negative 4 times positive 3 is negative 12. So it's negative 12. This is my answer. All right, let's factor. Factor is doing the reverse of expanding using the distributive property. I notice right here that I have 2 areas, so I can still use my rectangle diagram. My screen seems to be messing up. These are areas. So let's draw my rectangle. This is 6x plus 9. I want to think of something that divides both 6 and 9. 3 divides both 6 and 9. 3 times what equals 6? 2. And I need an x there. 3 times what equals 9? 3. Now to write my final answer, I write it as a length times a width. My length is 3 times my width is 2x plus 3. I'm done. That's my final answer. These are equivalent or equal. All right, let's see one more. I see 2 areas, so I'll set up my rectangle. Negative 14y and 21. If I can't think of something that divides both of these numbers, I could try a factor tree. 2 and 7, 3 and 7. These both have 7 in common, so their greatest common factor is 7. 7 times what is 14? 2. It also means to be negative and have a y. 7 times what is 21? 3. And again, I write my answer as a length times a width. 7 times negative 2y. It messed up again. That's so strange. Negative 2y plus 3, and that's my answer.